Hello and welcome to R&D Mathematics. Today we are going to talk about linear equations. Now, first of all, what is an equation? Equation is something like this, where you have a left-hand side equals, that's why the name equation. So equal sign, there should be an equal sign which is equal to right-hand side. Now, is this an equation? Yes, that's an equation. Is this an equation? Well, this is wrong, but still this is an equation because there's a left-hand side, there's a right-hand side. This is an equation, yes, see? Exactly like this one, but in we have now 3 in front of x. How about, let's make it, yes, this is also an equation. If I had square term, yes, this is an equation, but it's not linear. All these examples previously, this is linear, this is linear, this is linear in one variable. For example, if we had 3x plus y equals 8, yes, this is linear, but now we have 2 variables, right? I think you get the idea. Another important thing, what is a variable? So variable, everybody knows variable. When we say variable, what comes to your mind is x, y, z, things like that. But what is it? A variable is something that you used for an unknown, right? Let's say you went to Walmart and bought 5 apples. And it costs you $14. Let's just say. And how much is an apple? Well, naturally, intuitively, you are going to divide 14 by 5, right? But what you are doing, we can explain this using the concept of a variable. For example, here the unknown thing is the price of an apple. So price of an apple, let's call it x. In that case, we have 5 of them, and so you bought 5 of them. 5x equals 14. And when you solve for x, you will have to divide both sides by 5. That's why you divided by 5. See, variable, we use it for unknown. And let me give you another example. Now I want you to think a number. Think, right? Don't tell me. Think. Don't tell anybody. Now multiply it by 2. Now add 10. Now divide it by 2. Now subtract the original number. Again, please double check, multiply it by 2, add 10, divide by 2, finally subtract the original number. If you have done it correctly, your answer is 5. If not, again check it, right? You must get 5. Now, how in the world I know that? Did I read your mind? Nope. Now let's see what's going on here. Let's take 3 people. Let's say person A. No, let's say person, Joan. And let's say Amy. And your teacher, me. So now let's say John took 3 and Amy thought the number 7. Let's see what will happen. When you multiply by 2, here you get 6, here you get 14. And add 10, you get 16, you get 24. Divide by 2, you get 8, you get 12. Subtract the original number, so 8 minus 3, you get 5. And here 12 minus 7, you get 5. See, no matter, it seems like it doesn't matter where you start, you still get 5, right? Now let's analyze this whole process. So let's think, your teacher, I thought, x. because I'm using the concept of a variable. It can be any number. So instead of a particular number, I'm using x in order to explain this. So when you multiply it by 2, 2x. When you add 10, 2x plus 10. When you divide by 2, now at this point, see 2x plus 10, actually I can take 2 is a common factor. I can take 2 out, then I get this, right? So see 2 into x, 2x, 2 into 5, 10. When I divide this by 2, these 2 will cancel. What I will have is x plus 5. The final step, you have to subtract. So x plus 5 minus x will cancel. The answer is 5. See, this nice little mathematical trick can be explained using the concept of a variable. So I think that is clear. Now let's move on to linear equations. Now let's actually start with seeing some examples. Now if I ask you to solve this equation, that means we are looking for a value. When you put this value into our equation, this equation is true. For example, let's say if we think x equal 1, what will happen? 5 times 1 plus 3, that is 5 into 1, 5, and plus 3, 8, 8 equals 23, that is wrong, right? So x is not 1. See, like you can guess it like that, but how many guesses do you need? Well, if you are not lucky, you will have to have infinitely many, right? It can be any number. So there is a proper way of doing it. The first step, what the idea, you have to isolate the term with variable. That is the idea. Then we can deal with it. So I don't like this 3. So what I need to do, 5x plus 3 subtract 3. If I do something to my left hand side, in order to balance that, I must exactly do the same thing to right hand side. Otherwise, you just cannot just subtract something and do nothing to the other side. You have to do the same thing. So I have 20 here. I have 5x here because 3 minus 3 is, it's gone 0. Now it's easy. You just have to divide by 5. You get x equal 4. See? Now you can double check by plugging it back here. So 5 into 4 is 20 and 3, 23. Yes, correct. Now let's see a little bit more complicated one. Now in this case, again, the same idea, you have to isolate your variable, but we have a problem here because your variable is spread everywhere. What I would suggest is to distribute and take x terms together. So I have x, you have to be careful with minus, so minus 3x minus 3. Now simplify as much as possible. Right hand side you get minus 2x minus 3. Left hand side 2x plus 1, right? Now I can add 2x to both sides because I like to have my x's, all my x's in left hand side. See, when I add 2x, in order to balance that, I must add, let me choose another colors. See, this blue color part is exactly the previous equation, and the green color part I am adding 2x to both sides. Why am I doing that? Because I don't like this negative 2x in my right hand side, so it will cancel with this, right? So I get 4x plus 1 equal negative 3. Now I need to take this 1 to other side, or you can subtract 1 from both sides. Negative 4x. So you divide by 4, you get x equal negative 1. Now that is the answer. Now there are a few places that I have to emphasize. Now look at here, these guys. At this place to this place, what I did was I add 2x to both sides in order to get rid of this minus 2x. Now in an equation, let me explain over here. Let's say another equation, right? Simple one. Now here, I want to get rid of this negative one. So what we have been doing, adding one, right? This will work. But when you are comfortable, adding one in order to get rid of negative one is same as you are taking that negative one over to right hand side. Then what will happen is the sign changes in plus one, right? Or if you had like this, in this case, when you take this over to left hand side, it will become negative sign. See, at this step right here, instead of subtracting minus 1, yes, that's what's happening. But once you are comfortable enough, you can simply take this to other side by switching the sign of it. For example, if you had 5x minus 8 over 3 equals 9, well, this guy will go to other side, but you have to remember sign will change, right? You can remember it like that. That's an easy trick. But again, what's happening mathematically is you are adding or subtracting the same number to both sides in order to get rid of the unwanted terms. Okay, I think that's clear. Now, these are simple linear equations. Let's see another one like this. How about this? Now, this is a little bit different because, well, this time, let me show you. The previous equations, they are just equation. You didn't see anything in the denominator. For example, here 3, that means 3 over 1. Here 1, here 1, here 1. Everything was nice. But now we have denominators, other numbers. In this case, what you need to do, you have to take LCD. That means least common denominator. Sometimes we call it least common factor. Now LCD of these three numbers 5, 10 and 2. So least common denominator. That means we are looking for a number that is a multiple of all three numbers, all of these numbers. So, well, it's really easy with these numbers. What you need to do just by observation, well, the number that you are looking for, the number you are looking for must be either the largest number or greater than it, right? Because we are looking for a multiple. So look at your largest number, 10. Can you multiply 10 by 5? Yes. 10 by 10? Yes. 10 by 2? Yes. So this is our least common denominator. And what you need to do, multiply the whole equation by least common denominator. So I suggest you to do it using parentheses. So you put a parentheses to your left hand side, right hand side. See, you put a big parenthesis on your left hand side and another one your right hand side, and then put your least common denominator out of it, because then you won't miss anything. So now term by term, this guy by this guy, 10 into 3x over 5, this guy to this guy, minus 10x, this and this, 10 into this and this, minus 10 into 5 over 2. Now do the simplifications. 5 times 2, so 6x, minus 10x, 10 will cancel, so x, well, 2 times 5, so 25. Now you can take all the x's to one side, so let me see here, negative 4x, x minus 25. I will take this x to left hand side, so it will become negative, so negative 4x and one more negative x, I get negative 5x equal negative 25, and I'm almost done. What I need to do, negative 5x equal negative 25 divided by negative 5. So negative 5 divided by negative 5, that's just 1. So x equal negative 25 divided by negative 5, 5, right? So the most important thing that you learned in this example was you have to find the least common denominator. And let's see one more example of this kind. So how about x minus 3 over, now in this case, You know what? Let me first write down the equation and explain you the difference between this example and the early example. Yes, they belongs to the same category, but look at this. In this example, the term involving x is just x. You didn't see x minus 3 over 10 or something like that. But in the next example that I took, now you have to be careful. You have to use the parentheses as well. Now, least common denominator of 3 and 6. That's 6. That's easy. So you have to multiply the whole thing by 6. First, put a big parentheses. 1 minus x minus 6 over 6. Now again, this is a place where it's little bit confusing, even in textbooks. Sometimes, you know, sometimes the problem appears like this in textbooks. But in my point of view, even the person who is creating the problem, it's even better when you have this, you see, this minus sign that belongs to this whole term. So it's better to do this. So let's do that. Now a big parenthesis and 6 here, 6 here. Now term by term. X. Again, when you do term by term, not like in previous, let me show you, previous case, I just write down without parenthesis. But now I want you to do this. There's a reason. Because there are minus signs. Even here, negative 6, do this. And then 6 into 1, and that's just 6. And 6 into minus 6 over 6. So I really recommend using parentheses. Now, term by term. So 3 times 2. So 2, let's distribute this. 2x minus 6. And then 3 times again 2. You have to be careful here. Minus 2 into x minus 2x. Minus 2 into minus 4 plus 8. 6 minus 6 will cancel, and that means you have 1 here. When I divide 6 by 6, that's just 1. So minus 1 into x, minus 1 into minus 6 plus 6. Now let's take all the x's together. Right hand side we have a minus x. So when I take it to left hand side, it becomes plus x. And here 2x and negative 2x will cancel. So all I have is that x coming from right hand side. So minus x, when it comes to left hand side, it's plus x. And here 8 and minus 6, I get 2. When it goes to other side, negative 2. So I have here 12, 6 and 6, 12, minus that 2, I get x equal 10. That is my answer. Now I think that's enough example for today's videos. In the next video, now let me see, in these examples, even though we talked about things like this over 6, but we never talked about things like this, x in the denominator. Now that's what we are going to do in the next equation. They are known as rational equations. And thank you.